Hello, our today presentation is about uh, from prompt to protection LLM enabled in context learning for smart public safety UAV. Okay, in this video we investigate how we can utilize and apply LLM enabled in context learning uh, for public safety UAV for emergency scenario. Public safety UAV enhance situational awareness in emergency response and post-disaster. Its agility and ability to optimize mobility and establish line of sight communication make it critical for managing emergencies such as disaster response and search and rescue. My name is Yusuf and I'm going to present this video. Okay, here you see the outline. We start with introduction, optimization approach, and continue with in-context learning, task description. We provide example of task description, and finally present the reference, which is a word from me. Okay, introduction. While deep reinforcement learning has been applied to optimize UAV navigation and control, it is it has a complex training process. As all of you know, deep reinforcement learning algorithms have a complex process for training. They have low sample efficiency and they suffer from simulation to reality gap. Okay, for example, in emergency scenario, we quickly want to deploy the DRL solution, but we may face with problems such as simulation to reality gap. Okay. Recent advances in large language model offer a compelling alternative. With a strong reasoning and generalization capability, LLM can adapt to new tasks through in-context learning. Okay. Later, I will discuss this more. By using in-context learning, LLM can adapt to new tasks by just using a few examples. Okay. Uh, so, deploying LLM at network edge rather than in cloud further reduce latency and preserve data privacy, making them suitable for real-time mission critical public safety UAV. Okay, this video investigates the integration of LLM enabled in context learning with public safety UAV to address the key functions such as path planning and velocity control in the context of emergency response. Overall, in this video, we show that how we can integrate LLM-enabled in context learning for UAV in emergency scenario. Uh, as I told, deep reinforcement learning have some problem. They have complex training, simulation to reality gap, and low sample efficiency. We need solutions that are more adapt adaptive, okay, that better adaptive to the sense of emergency, okay. Okay, here in this slide, we have provided a comparison between different optimization approach for public safety UAV. We have three items: DRL optimizer, diffusion model plus DRL optimizer hybrid approach, and LLM optimizers. For example, from the point of training requirement, DRL optimizer, as all of you are aware, have complex model training. When we combine DRL with diffusion model, we have an improved model training. An LLM optimizer such as ICL, there is no retraining or parameter update. Okay, also we can compare them from the point of deployment speed, not compatible with urgent requirement. DRL solution are not compatible with urgent requirement such as emergency scenario. Uh, its combination with diffusion model improve real-time performance, and ICL has rapid adaptability and deployment. Okay, that's why this option is very suitable for emergency scenario. Okay, uh, from point of adaptability, DRL optimizer are action oriented. They lack flexibility. When combined with diffusion model, they improve adaptability, and the ICL facilitate rapid task adaptation. Okay, uh, DRL optimizer are a state of the art for UAV assisted sensor network, and when combined with diffusion model, they are robust solution for complex scenario. And ICL or LLM optimizer are flexible and generalizable. Okay, we can easily generalize them. And what are their key limitations? For DRL optimizer, we have a slow training and deployment. We may have simulation to reality problem. Uh, when combined with diffusion model, it still require complex integration, and the convergence property of the ICL is not proven yet. Okay. Okay, so overall in this table, you saw a comparison between DRL optimizer, hybrid optimizer, and LLM optimizer from different point of view. Okay, in context learning, what is in context learning? Uh, in context learning enable large language model to learn from contextual information embedded in prompt. Okay, we it enable LLM to learn from the contextual information, to learn from example, and what is its capability? Allow LLM to generalize across tasks by leveraging pre-trained knowledge and adapting to new tasks through example-based prompt. Okay, it's this in context learning allow large language model to generalize across tasks and adapt to the new task by using and observing some example of the task. Key consideration, the design of demonstration. This is very important, including example selection, formatting, and ordering strongly influence performance and should be carefully crafted. Application in public safety, in context learning, offer a lightweight method to facilitate key functions such as task planning by reusing prior solution as the input prompt, supporting fast adaptation in emergency. Okay, in this slide, you see example that provide an overview from the whole process. We have task description that is fed to the LLM to generate the response. In the left side, we have a UAV and we have some sensor on the ground. Overall, we have a UAV assisted sensor network. UAV interact with this sensor, collect sensory data, and pass them to the LLM. Task description is shaped, and based on this task description, LLM generates a response, and this response is given back to the UAV. Okay, and what are the components of the task description? We have task goal, we have input data, we have role and constraint, output, feedback. Okay, these are the key components for task description. The LLM received the data from the unmanned aerial vehicle and shape and uh, format the task description and then generate a response based on this information for the next round of the operation. We have also a system prompt that is a special kind of instruction or message given to language model to set the overall behavior, style, or roles for how it should respond throughout a conversation or task. For example, we can force LLM to follow ethical guideline and safety rules. Okay, this system prompt is also key. So once again, the overall process: UAV interact with the ground sensor, collect sensory data, pass the collected data to the LLM. A task description is shaped. The each element is filled, and the LLM based on this task description generate a command and pass it to the UAV for the execution. Okay, here in this slide, you see practical example of the task description. Okay, for example, this task description is for velocity control. This one is for trajectory optimization. This task description is for power control. This task description is for optimizing the transmit power of ground sensor, and the last one is related to the data collection schedule. For every task that we want to solve using LLM enabled, I feel we have to provide a task description, a detailed and accurate task description, and feed this task this description as a part of the prompt to the LLM to generate response for us. For you may notice that this feedback loop in task description is very critical. Also, all of them are critical, but this feedback loop is very critical. As you can see here, for example, for optimizing velocity, input data is real-time sensory data, including current location, fuel length, and channel condition. It optimized velocity based on current location, fuel length, and channel condition. We have some role and constraint. The slow mobility of UAV can lead to the buffer overflow, and fast mobility of a UAV can harm the channel condition and increase communication failure. And we also specify the output a velocity that minimize the packet loss. Okay. Uh, okay. In this slide, we saw example of the task description. Okay. Thank you very much. The reference for this video is my paper that is available on archive, from prompt to protection, large language model enabled in context learning for a smart public safety UAV. It's a worth reading paper. I strongly recommend to go and download this paper and read it. Okay. Thank you very much. I hope you enjoyed this video. If you learned something from this video, I appreciate to like and subscribe.